it is like intelligence is the patent of human beings, right? Only human beings can perform certain tasks, and machines cannot perform those tasks. In 1950s, Alan Turing proposed Turing test that machines can imitate human beings. Thereafter, several developments happened, and we have seen several fictitious movies. Part of those tasks are really imitating by machines nowadays, where we have Tesla's autonomous car, which is able to drive on highways and learning to drive in traffic as well. Right. So these kind of tasks are still known as only weak AI or narrow AI. So the well-known applications, what we know called Amazon's Alexa, IBM's Watson, and Apple Siri, right? So the interactive chatbots, which can order a product for you in the online market, etc. So these kind of supporting human beings, even though they look great, so they are categorized as weak or narrow AI. And in future, we can expect artificial general intelligence or artificial super intelligence, which is expected to develop cognitive intelligence to the machines, where the machines are self-aware, conscious, and they have ability to solve problems, learn, and plan, right? So they can learn new things and plan and act on the environment. So with the super intelligence, the human brain is imitated by the strong AI systems in future. So if you see the timeline of artificial intelligence, right from the 1950, where Alan Turing proposed the Turing test. So what is Turing test is like when you are chatting with the unknown person, right? So you cannot confirm whether the unknown person is male or female immediately. The same way, like there will be a environment, a blind environment, where a human being is participated in a computer chat, and the human being who is participating in that computer chat, so the chat is known as Turing test. The person has to test the two people who are chatting from the other side and decide which one among the two people are human being and machine. So it is discriminating between the machine and human being. If that task is going to be tough for the person who is testing for around reasonable time, say 10 to 15 minutes, if he cannot detect who is human being and who is machine, that means that machine has equally behaved like the human being, and it is difficult for the person to detect that it is a machine. Right. So like what we do in CAPTCHA. In CAPTCHA, like we'll be entering some text which is difficult to understand by machine. The machine cannot understand the CAPTCHA test. Only human beings can understand. So such a morphalized text will be there in the CAPTCHA screen, right, where only human beings can understand and present that. So there in 1955, in the Dartmouth summer workshop, John McCarthy has coined this term artificial intelligence and AI born there. So in 1950, the Turing test proposed that computers can behave like human beings. But the term AI was not coined in 1950. Only in 1955, the term AI is coined by John McCarthy at Dartmouth summer workshop. And later on, there were some developments like a robot, Eliza chatbot, and shaky, which can and then during this period AI was dropped, right? So they have not adapted much. So again, 1997 with IBM's Deep Blue, which has won the chess match against the champion Gary Kasparov. So that time again AI come into picture, where IBM want to promote the supercomputer. So to promote that supercomputer, they have taken this AI as the task. Right. And then 1998, there is a MIT introduced a robot called Insofar, and 99 we have another robot Aibo by Sony, and IBM's Watson, again interactive bot. So Eugene is a chatbot which passed the Turing test, right? So Eugene behaves like a 13-year-old Europe kid, right? So when you chat with Eugene, so you'll feel that as if you're really speaking with a 13-year-old kid, right? And then we have Alexa, right? So entertaining us, and the voice interaction, we can search the knowledge as well as entertainment from the internet, and also it can complete some of the shopping tasks. So Microsoft chatbot Tay is there, and finally AlphaGo is the computational intelligence thing which we are discussing today, right? So if you see here, 1997 itself, computer can play chess, whereas till 2017, around 20 years, computer cannot play Go. Go is a game like Chinese checkers, right? So there will be two coins, white and black. And if you take chess game, for the first player, he can choose one of the 20 moves, right? Whereas if you take Go game, the problem is there will be 350 moves for the first player. So the breadth of the set is vast, and there is no computer till 2017 to implement that. So Google's AI platform AlphaGo, with the supercomputing power available on the day 2017, right? So, and the AlphaGo is a neural network which will predict the better path and the utility of the intermediate state. So the strategy of the player along which state he has to travel to win the game. So each particular board configuration, the neural network is finding the utility and directing the strategy of the player, to where the game is having 2 to the power of 170 possible positions. So such complex problem it is. So to solve these kind of complex problems, computational intelligence is the field where we can implement, even though practically impossible to solve such problems. So what is computational intelligence? Many real life problems cannot be translated into binary language. That is, we don't have algorithms. In order to write a computer program, we need algorithm. Okay, so as for a software engineer or a computer science student, in order to write code, one needs an algorithm. But some of the problems don't have algorithms to code. So for such problems, we can deal with soft computing techniques like artificial neural networks, swarm intelligence, artificial immune systems, fuzzy logic, and evolutionary computational algorithms like ant colony systems, genetic algorithms, particle swarm optimization, etc. So computational tractability is the measure. So if you take linear search, you have big of n complexity, and if you take sorting, you have some big of n log n complexity. Like that, we have some computational complexity associated with each of the computational problems, and the time taken by these problems will be varying based on the size of the parameter, right? So say search or sorting, so the number of elements in the array, right? So based on that, the time taken for sorting a search will be varying. And if you see here, in some of the problems, suddenly the time will grow exponentially beyond certain value of the parameter, right? So here, if it goes like when the number of jobs are say 30, it will go around days, and even though we have an algorithm to solve the problem and we have implemented on the computer, but we cannot utilize it if the length of the jobs is heavy, right? We cannot utilize the computation. So that is the computational tractability. Up to certain number of load only we can utilize the software program. So in such situations, we can use the alternate, that is the computational intelligence. So these are all the problems where we don't have a polynomial time algorithms. Right? So these problems are known as NP-complete problems, which needs a non-deterministic machine, means simultaneously which can perform several operations. And there is no limit for that. How many simultaneous operations we are expecting? Any number of simultaneous operations, which is practically impossible. If we have such machine, we can easily solve this. We can write algorithms to solve these problems. In fact, these problems demand that much computation, computationally intensive or exhaustive. Right? So for such problems, we can find the solutions. May not be optimal solution, maybe near optimal solutions in reasonable time using evolutionary algorithms. So what is evolution algorithm is, which will start with a random solution, right, which is not the exact solution for the problem, but randomly we'll take a solution and we'll check the quality of that solution, and from there we will try to improve the quality of the solution. So you can see it as a hill climbing approach, where we'll be starting somewhere random, and from there we'll be trying to improve the quality of the solution. So when you go with this hill climbing type of methods, the problem is if the solution space is the solution space will be convex or concave like this, right? Randomly you will be starting at a particular location. Say for example, you have started in a particular location, then the best solution what you're going to find will be this. And it will stop there. It will stop there, right? Which is local optimum for this region. Local optimum for this region, right? So you cannot guarantee a global optimum with the hill climbing kind of approach, right? So population-based algorithms, what it will do is they'll take many initial solutions. So initial solution number 1 here, say another solution here, and another solution here, another solution here. So many of them, so we'll get many of the local optimums, and best of the local optimum we can consider it as global optimum. Again, we cannot guarantee the global optimum here also, but better than hill climbing. And for most of the cases, we're getting global optimums as well in reasonable number of generations. The thing is, we don't have a algorithm which guarantees optimal solution in reasonable time, or a fixed time like time bound, upper bound like a polynomial function like big O of n or big O of n square or big O of n log n or n factorial. Like so, some problems have complexity like big O of n factorial. So which is very exhaustive. Like if you go for 100 number of parameters, the factorial value will be exhaustive. So which makes, even though we have a computer or we have a supercomputer, which makes the utility is impractical. Like so, we cannot utilize, even though we have an algorithm supercomputer, we cannot utilize because of the exhaustive demands of the exhaustive computational demands of the problem. The nature of the problem is like that. So these kind of problems, we can come in an alternative way to solve them in reasonable time with evolutionary algorithm. Combinatorial optimization problem in which you can arrange some of the elements. Say, for example, in VLSI design, the layout. So within the processor, the components are within the integrated circuit. So where they have to be placed, So